Okay, so thanks everyone for joining. Thank you so much for taking time from your busy schedule and joining a session. We really appreciate your presence in these sessions. This is the last session in module 1. So module 1 is all about history and the evolution of Wi-Fi and the Wi-Fi ecosystem in general, right? From module 2 onwards, we're getting into the core of the technology. But as I mentioned before, what I always like to do is before I get to the core of any technology, I like to understand what's around it, right? And so module 1 was designed to understand what's around it. So we covered the history, the evolution of the technology. We talked about the various deployment models, different types of ways in which Wi-Fi is deployed in homes, in enterprises, in stadiums, and so on. We talked about the standardization process of Wi-Fi, and how the standardization process goes through. We talked about the various challenges with deployments. So, and the different types of companies that are involved in the Wi-Fi ecosystem. We talked about how the entire product lifecycle goes through, where all the way from early stage ideation to design to development to deployment to post deployment. So we talked about all of those things in this particular module. This last one is going to kind of introduce you to the basic concepts of a Wi-Fi access point. And then after this module, from module 2 onwards, we'll go into the core physical layer, MAC layer, and all these other things that are very specific to Wi-Fi technology. Right, so before we jump into this section and we talk about the building blocks of a Wi-Fi router, let's quickly recap what we talked about in the last session. So in the last session was all about the WLAN standards amendments and basically the standard extension. So we talked about how the IEEE standardization process works. We talked about how basically there is a base standard that was developed by IEEE over a period of time. And then when we want to create a standard, we create a initial study group, and the study group studies the ideas, comes up with a project authorization request, and then from the study group it becomes a task group, and the task group goes through various process in the standardization process. It goes through various steps, and through this process there is a lot of technical aspects to it. There are a lot of political aspects to the standardization process. There are hundreds of member companies that are involved, and we talked about how that entire process works. And then we talked about amendments. Anytime there is a new requirement, a business requirement or a technical requirement that was not covered by the base standard, let's assume that you want to add lower latency for Wi-Fi, or you want to add better security. So you can actually go and start a standards extension, basically form a group and standards extension, and then that goes to the whole standardization process and eventually gets rolled into the standard. So we talked about the IEEE and how it works in detail in the last session. And we talked about other organizations that help the Wi-Fi evolve in its ecosystem, right? We talked about organizations like Wi-Fi Alliance that is responsible for certifications, initial plug fests, putting technology together and simplifying the base standard into something that's easy for people to use and understand. Talked about WBA, Broadband Alliance, we talked about Broadband Forum, and then we talked about open source technology in general. So a lot of the technology that we use in Wi-Fi, the technology that goes into an access point like this, is pretty closed, right? So the people who actually developed this, the company who developed this access point, would write their own software and basically they design their own hardware in many cases, and then that's closed. That's only up to them to use. And then when they distribute the firmware, they distribute it as a binary, right? And so the source code, you don't have access to the source code, right? But there are initiatives to open source Wi-Fi technology, and there are initiatives like OpenWRT. Many of you might know if you are working in the Wi-Fi space. And then there is a new initiative called Open Wi-Fi, which is trying to open source all of the Wi-Fi access point software, the firmware, and also the cloud controller software and firmware as well, is all open sourced, right? So someone, if they want to start a new Wi-Fi access point company and have an access point and a controller, they can go become a member of Open Wi-Fi and basically start using the code and save themselves from 5-10 years of R&D process that normal companies go through, right? So we talked about a number of initiatives in the open source side in the last section. There is Open Wi-Fi, Open Mesh, Open Roaming, and so on, right? And then we talked about the public sector. It's getting involved in the Wi-Fi space. There are city-wide mesh networks. There is this program called PM Vani in India. It's a Prime Minister wireless access network infrastructure, and basically it's an initiative from the Indian government to actually provide Wi-Fi network access to all corners and all rural areas in a country like India, developing country like India. So we talked about that in the last section. And then there are other organizations that are organizing events, summits, podcasts. There is Wi-Fi Now, there's Wi-Fi Knowledge Summit, Mobility Field Day, and they all actually, all the industry experts come together. They do presentations about the technology, about their products. Different companies come to these summits. They present all the latest and greatest technology that they have developed in their products, and all these recordings are posted on their website. So it's a great source for someone to actually go and watch all these presentations and get up to date on what's the latest in the technology. And some of the links have been posted in the references section as well. We talked about podcasts, and then for those of you who are interested in finding jobs in wireless LAN space and want to basically have some skill certifications, there is an organization called CWNP, which helps with the vendor neutral standards or certifications. So you can go to CWNP, and there are different types of certifications you can go for, study and write exams and so on. There are, of course, more vendor specific certifications, like Cisco has CCNA program, CCIE program. There are programs from Aruba, Juniper, and all these other larger companies as well. So that is the entire kind of ecosystem around or maybe I should call it the support system for the Wi-Fi technology. It's not necessarily the ecosystem, but it's a support system. And all of these various entities and these stakeholders support the technology and its growth and its widespread adoption in many ways, all the way from standardization to help people find jobs and get skills, right? So we talked about all of this in the last session. So if anyone missed it, you can go back and watch the recording. The recording should be uploaded on the website. For those of you who are not connected, you can connect using our website. All the details are there. That's the QR code on the left-hand side. You can access the course material, the class notes, the slides, the video links, and all of that are all uploaded for the last 3 sessions. If you have not registered to this webinar, you can here. And if you want to join this WhatsApp group that we have created, where we share details and answer questions and have discussions, that is another good place for you to join. It looks like we have close to almost 1,000 participants now in the WhatsApp group, which is pretty amazing, right? And these are from all over the world. It's pretty cool. And so this is about the previous session. So now let's just dive into the current session, which I'm quite excited about, where we're going to talk about Wi-Fi router or Wi-Fi access point, and that's the start of this particular session. We're going to talk about Wi-Fi routers. Okay, so let's start with the phone that we all know. So when I want to connect to the Wi-Fi network using my phone, right? So what will I do? I'll go and open my basically the Wi-Fi interface and settings and look at the list of all the networks that are available, and then select a particular network that I want to connect to and hit connect, and then I'll connect to the network. But how am I getting this list of all these Wi-Fi networks? How is my phone able to tell me these are all the Wi-Fi networks that are available in your immediate vicinity, right? So there has to be something around this particular phone that is allowing me to connect to the internet, and that is the Wi-Fi router, right? So if you're in your house, in your apartment, then you select a list of Wi-Fi networks. It'll probably show you like 5 or 10 different networks at different power levels. So maybe the Wi-Fi router in your house has very high signal, but then maybe your neighbor's Wi-Fi router, you can see it, but maybe with a little lower signal, right? But at the end of the day, you are connecting to the Wi-Fi router or the Wi-Fi access point, and that is what is providing internet connectivity. And the fundamental, the most important element in Wi-Fi is basically your Wi-Fi router or your Wi-Fi access point, right? And we are going to now dig deeper and understand what is inside a Wi-Fi router, what is inside a Wi-Fi access point, what is the difference between a Wi-Fi router and a Wi-Fi access point, and so on. Okay, so the 2 most common types of Wi-Fi router/access points that we see all around us are the residential Wi-Fi router. So this is a residential Wi-Fi router. Most of these have fancy colors. You'll find some interesting gaming routers that are really large. I showed some of them last time that are basically quite expensive. So this is a residential Wi-Fi router, right? And we see these routers everywhere in our homes and wherever we go. And then the second type of Wi-Fi router or access point that we see is the enterprise Wi-Fi access point, right? So normally the enterprise Wi-Fi access points are generally white in color. You can see like most of the ones that you see are like, they look like this, right? Why are they white in color? Because in an enterprise environment, you normally mount these Wi-Fi access points in the ceiling or on the wall, which has normally like whiter, lighter colors. And so you want those to blend into the walls, right? And you don't want them to be necessarily seen in an enterprise environment. And so normally they are kind of these colors. So these are the two types of Wi-Fi access points / routers that you would see in a normal Wi-Fi world that we live in, right? So we're going to talk about these in more detail. Okay. So what is inside a Wi-Fi router, right? So if you open a router box like this, we actually disassembled one of these Wi-Fi routers here. It's a residential Wi-Fi router. And if you see inside, there is this board. I know it's hard to see from the camera, but this is basically everything that you see inside the router. That's all of it, right? So on the board, you'll have, if you see all the modules are on this side here, and there is this huge heat sink on this one that is hiding everything. So to basically provide some cooling, and so you cannot really see it. But on this, behind the heat sink, you will see the radio modules. And you will see all the other components. You will see the basically the memory modules, the CPU, all these other modules that are normally on a standard Wi-Fi router board, right? And then you will see also these radio connectors. We call them basically U.FL connectors. These are the small antenna connectors on your board, on the Wi-Fi router board, and you use these U.FL connectors to actually connect onto the board. And from there, you see an RF cable. Normally, it's referred to as a pigtail. It's called a pigtail. And these RF cables will come and connect to these antennas, right? So these are the antennas that you have on this board. And these antennas will go on one of the corners. Somewhere there should be a mount where it goes onto one of the corners. And this is the antenna that's inside this Wi-Fi router, right? And that's how the antennas connect to the radios, and the radios are behind this heat sink. It's hard to see from here, but the 2.4 gigahertz, 5 gigahertz radios are inside, right? So on the board, you have many things, right? You have the radios, you have the memory, and you have all these interfaces, right? You have these Ethernet ports that are used for switching. You have the power module that gives power to the unit. You have the LEDs on the system, and various other components. And of course, you have these USB interfaces as well, and then the radio modules. Actually, it's hard to see here, but these are the radio modules that are inside on the board here, right? So that's what's inside a Wi-Fi router, right? That's what's inside the board. And I again posted some references if you want to see some more pictures and things like that, right? So now, what are all these things doing? And the same thing with the device, right? Okay, what is on your laptop? So one of the early sessions, I talked about these PCMCIA cards that actually go into the laptop. That's the early version of the client cards that we used to have that would slot into the laptop. But nowadays, a laptop comes with, most laptops and devices come with built-in Wi-Fi radios. If you see in this picture, you can see these. This is the Wi-Fi radio. Actually, I have an sample here. So this is like a back of a laptop. I hope you can see it. Basically, you see here that there is this Wi-Fi radio here. So this is a Wi-Fi radio. It is a single antenna radio. So there is only one radio spatial stream, as we call it. And it's also connected to an RF cable. And this one goes through an antenna, which is somewhere behind here. And this is the radio module, right, that you have on the laptops, right? So normally, companies like Intel would make these radio modules. In some cases, if you're good with opening up laptops and things like that, you might actually be able to replace these modules and install a newer module if you're good with electronics and doing these kinds of things, which would be an interesting thing for you to do, right? So that's what a client device is. And similarly, you'll have a Wi-Fi module inside your phone. Of course, I cannot disassemble my phone right now, but I'm sure you'll understand that there is a Wi-Fi module radio inside the phone as well. So there's this interesting place where you can actually go and look at these pictures that are these pictures of all these APs, most of the products that are available in the market. You can go to this website fccid.io and you can type in the model number of any Wi-Fi router or access point, and it will take you to a page and it will show you all the details. If it is certified by FCC, it will show you all the test reports, the EMC reports, basically the emission reports, the UL reports, the power, the transmission power reports, the DFS certification reports. All those reports are all there. Test reports are there, and pictures of inside and outside, and details of all the components are all there on this website. So I put a link to this website in the references. So for those of you who are interested, and if you have a particular model of a Wi-Fi router that you want to see what's inside it, and is it dual band, is it tri-band, what kind of radios it uses, what kind of chipset it has, is it from Broadcom, Qualcomm, is it from Marvell, is it from MediaTek, who is it from? If you want to find those kinds of details, you can actually go and go to this website, and you should be able to find those the details about any Wi-Fi router. So as an assignment for some of you, it would be interesting if some of you you're new to Wi-Fi, maybe you can, when you go home, you can actually check what type of Wi-Fi router you have in your home, and try to search the internet, and maybe go to this website, type in that model, and try to see what type of radios are in it. Is it, what type of chipsets are there? What type of standards does it support? Is it a Wi-Fi 5, Wi-Fi 6, Wi-Fi 7? Of course, Wi-Fi 7, mostly those APs are not available right now, but is what number of antennas does it have? What kind of technology it supports? You can actually maybe go learn all those things as a interesting exercise for those of you who are new to Wi-Fi. That would be an interesting thing to do. And if you find anything interesting after you do this research, please send us basically your findings. We would love to hear from you. You can post it in the WhatsApp group or send an email to the training email, and we'd love to hear from you about that. Okay, so now let us get into what is inside we looked at the hardware. Now basically we look at all the blocks, the software blocks inside this what we call as a router. Now the Wi-Fi router has evolved over many years. What I'm showing you right now is a modern day Wi-Fi router, but that's not how Wi-Fi routers were in the past. They were very simple. They were only doing some basic things, right? A modern day Wi-Fi router does a lot of things, right? It does a lot more than just routing and access point functionality. So what does a modern day Wi-Fi router do? Of course, it's an access point. So remember, the access point, the function of an access point is to actually act as a portal. So it would convert your wired network into a wireless network, right? And it is a pure layer 2 device. It's only operating at layer 1, layer 2. It does not even know IP. It does not even IP layer, right? It's a pure layer 2 device. All it does is it takes Ethernet packets, frames that are coming from the Ethernet interface, and then takes out those headers, puts in a Wi-Fi layer 2 header or a .11 layer 2 header, and sends it out to the air. So the responsibility of an access point is to operate at layer 2 and do the physical layer, file layer functions, and the medium access layer or the data link layer functions, right? And convert wired to wireless. That's all the access point is doing, right? That's its job, right? So that's one of the parts of what a modern day Wi-Fi router does. It does the function of an access point. It also does the function of a switch. So normally, what is a switch? We all know what a switch is, right? Mostly a switch is used in the wired network. Again, most of the time, switch is considered as a layer 2 device. It is allowing you to connect multiple devices on your network, in your local network, in your local area network, right? Within your layer 2 domain, right? So the switch functionality is also there inside the Wi-Fi router. So you see this Wi-Fi router, it has all these Ethernet ports. And so now you can connect these Ethernet ports to your desktops, to your wired networks. And then these ports can do switching, just like a normal switch that you use, right? So switching functionality is also built into this unit, right? What else can this do? This can do routing functionality. So normally, in the olden days, there used to be a separate network element for routing functionality. So what does a router do? A router allows you to cross your layer 2 boundaries, and it allows you to get into the layer 3 space, and it allows you to connect to other networks. Remember that the access point, the Wi-Fi router, is only creating its own local area network. It is a wireless LAN or a wired LAN. A LAN means a local area network. So it's only a local area network. The router allows you to connect from the local area to the wide area network. So basically, router will allow you to interact between networks from the local area to the wide area network. So that functionality is also built into the modern day Wi-Fi router, right? And we'll talk more about what those things are. And then there are various services that run on this particular Wi-Fi router. What are the services? There is DHCP, which provides IP addresses. There is DNS services, which does name resolution, and there is a HTTP service. And so why do we need HTTP services and so on? You need to run a web server on this device, right? So there is a web server running on this device. Why do you need a web server? Because you need to be able to configure this device. So when you connect to one of the ports from here to your computer, or when you connect wirelessly to this device from my laptop, I can connect, when I connect to this, I can actually connect to its default IP address. Let's assume the default the default IP address is 192.168.1.1, and when you go type in that in your browser, you should be able to now basically connect to the router through the web interface. So basically, it will call the web page that's on the router, and then from the web interface, you will be able to do various settings on the Wi-Fi router. You will be able to set up networks, you'll be able to set up security, you'll be able to set up fire policies, and so on. And so the web server itself also runs on the Wi-Fi router, right? And other services also will run on the Wi-Fi router. Okay. So what else it does? It can also do a modem function, right? Remember one of the sessions I was showing you. This is let's say a Wi-Fi router from Comcast, from Xfinity, right? So this one has basically this coax ports, right? So remember we talked about how Wi-Fi network can connect to the internet using various backhaul mechanisms through basically through fiber, through MoCA or coax, or through cellular, and so on. So if you have a coax cable coming to your house through your cable TV network, then that coaxial cable can go into this, and inside this sits a modem that actually converts the data that's being run on the coax into the data that's being run on the normal Wi-Fi or Ethernet, right? So that is the modem that actually does the modulation and demodulation part within this particular device, and that modem is also built into this device. It's not very common. For example, this router does not have a modem built into it. This one does. So it differs based on the type of devices you have, but the modem functionality can also be built into the Wi-Fi router. And then you have the firewall. Now remember, in traditional networking in olden days, every one of these is a different box. So for a switch, there is a different box. For the services, you have a different box. For the firewalls, you have a different box. For a modem, you have a different box. And so there are all different pieces of hardware. Now, a lot of this is all integrated into the modern day Wi-Fi router, right? So for example, firewalls and policy engines are into the Wi-Fi router. Why do you need a firewall or a policy? To actually apply certain rules, to deny a certain type of traffic. Let's say you have a Wi-Fi router in your house and you want your kids not to watch a certain type of programming, right? So you can apply parental controls. The Wi-Fi router is now, which is a Wi-Fi router which is supposed to be a pure layer 2, layer 3 device, can now do deep packet inspection and actually can look at application traffic and identify that this particular traffic stream that is coming into the local area network comes from a malicious website or a website that we don't want to access, and so it will block it, right? So that kind of basic firewall functionality is also built into the modern day Wi-Fi router, right? And then the new entrant to some extent is all the IoT devices we have in our houses, right? So we have the smart bulbs, smart switches, we have the Alexas, we have all kinds of other gadgets that are in the house that are all IoT devices. Not all of them would operate on Wi-Fi. Some of them use Bluetooth, some of them use Zigbee, some of them use different other radio technologies. Some of the new modern Wi-Fi routers that we are seeing also come with these IoT gateway functionality, where they don't just have a wireless LAN radio, They also have Bluetooth radios, and they also have Zigbee radios. And these radios can interact with the IoT devices and then actually basically act as a gateway for these IoT devices to connect to the internet, right? And so that is basically some new functionality some of these Wi-Fi routers do. So as you can see, there are so many things that this particular small gadget or device that you have in your house, depending upon how new and how modern it is doing so many things, right? Now, that is not how an enterprise Wi-Fi router works, right? So this is, I'm talking specifically about residential. In residential, the thing with the residential environment is you don't have all these other network elements. All you need to do is you need to connect this Wi-Fi router to the internet, and you get access to the internet, right? So which means that you have to run all of these things within the router itself. But enterprise is very different. If you look at an enterprise Wi-Fi network, on the enterprise side, let's say you take the example of a large office that has 1,000 employees, right? And you're deploying 100 Wi-Fi access points, right? Now you can build an infrastructure behind these access points, right? You don't need to do the switching functionality, the routing functionality, the gateway functionality, the firewall functionality, all inside this device. You don't need to do that, right? Because you can push all of that functionality to the infrastructure, right? Because it is a formal organization, there is a formal IT team, there is a wiring closet, and there is all these basically all this network that they're managing in one place. All of these functionality that we were showing before, the switching functionality, the routing functionality, the firewalls, the services, all of these things can be pushed to the network. And then this particular device can become a simple access point, right? And that's all it has to do. It can become an access point, and everything else gets pushed to the network. So many people ask this question, what is the difference between a Wi-Fi router and an access point? It's pretty simple. I mean, most of the Wi-Fi routers that we use do all of these things, and an access point doesn't do any of these, right? And it only does the access point functionality, right? That is basically the fundamental difference, because we have other network elements in the enterprise network that will handle all these blocks for you. You don't need to manage this within this unit. In a home, since we don't have that luxury, all of these services and all these modules have to be run within this device, right? And that is the fundamental difference, right, between enterprise and the home networks. As I was saying, residential Wi-Fi is only one device, and then there is the internet. But in an enterprise network, you have these APs. They connect to switches. The switches connects to the routers, and there are other entities, like you have your mail server, you have your FTP server, you have your web servers, you have your firewalls, gateways. All types of network elements are there in an enterprise network, right? Now, what is the advantage of pushing all this functionality to the core of the network in an enterprise situation? The big advantage is it is much easier to manage. The fundamental difference between a residential Wi-Fi network and enterprise Wi-Fi network is scale. The residential Wi-Fi network, you have one access point or one router. That's it. In an enterprise network, you potentially have hundreds of access points. Now, when there is scale, when you're trying to have hundreds of access points, then managing them becomes much harder. In your residential access point in your home, since you have only one Wi-Fi router, if something is going wrong, you want to change the network, you want to change security, you want to change password, you want to do any of those things, all you have to do is only one entity. You basically log into it. If you want to upgrade the software, you just log into it, you upgrade the software, you make your settings, and you're done, right? But in an enterprise, there are hundreds of access points. You cannot go to each one of them and configure them, right? So the only way you can scale that is by pushing all the configuration and management, everything up to the core of the network, and centralize it, right? When we centralize it, there is at the central level, there is all these rules and everything, configuration, everything can be done, and that configuration can be automatically pushed to all these devices, right? So in the 2000s and 2010s, those decades, most of the centralization in the enterprise network was pushed to what we call as controllers. These are physical controllers that are on the premise on the enterprise, right? And so there's a physical controller, there is an IT team that is managing it. It's a physical box that is sitting locally in the office, right? And that is managing all these Wi-Fi routers in the entire building. But as we came into the next decade, that all became virtual, and we all know how everything got into the cloud. Then the controller got into the cloud, and now it's all cloud managed. So not only the advantage with managing in the cloud is you don't have to basically restrict yourself to managing one site. You can manage multiple sites from one location, right? And so you push the configuration into the cloud, and let's say your company has 4 offices in 4 different locations in the world. Then you just have one cloud controller that is managing these 4 locations, and then you can click from anywhere, access any of these locations, and then check what's happening on the network and push policies, push configurations from anywhere in the world. And that's what the cloud controller does. So because of all this complexity in the functionality and the scale, the access point or the Wi-Fi router becomes a very, very simple device, and it's basically an access point, right, for the most part. And it doesn't do most of the other functions. That's the fundamental difference here. So if you want to configure a residential Wi-Fi router, you can actually go log into the web page. This is an example of the screen of the web page of a gaming router, a SUS router. You can connect to it. You can like set various things. You can go to the wireless section. You can set up passwords, type in the passwords and things like that. You can set the router in various modes. You can make it an AP, a repeater, a bridge, a mesh node, and basically you can change all those settings. You can type in passwords. You can actually these routers, as I mentioned, are very sophisticated, right? They have firewalls, right? You can set policies, right? And all these things these modern day Wi-Fi routers, residential Wi-Fi routers can do, right? You can, as I said, as an exercise, if you're new to Wi-Fi, go connect to your Wi-Fi router in your house. Normally, when you connect to a Wi-Fi router in your house, you'll get an IP address. Let's say you get an IP address of 192.168.1.10. Most likely, your default IP address will be 192.168.1.1, through which you can access the router. So you can go open up a browser, type in their address, and it's most likely going to take you to the web page, and then you can play with some of the settings there, right? So that's what a residential Wi-Fi router is like. But the enterprise, as I was mentioning, enterprise is all about scale, right? So now it is not about an individual single Wi-Fi router. It's about the entire network and everything around the network, right? So now everything is managed not at the router level, but at the network level, right? And the network could be your immediate building, your facility, or it could be the cloud managing the entire network from all over the world, right? As an example, I wanted to show you this and I've been using this for a long time. When I was early on, many years ago, I was learning about how cloud controllers function. You should all go try this out. Meraki, if you go to Meraki's website, you can actually type in some information and actually go into an instant demo, right? An instant demo will allow you to see how a cloud controller on an enterprise network actually works. Now, I have a more detailed session about control architectures and things like that. That will come later in the course, but I'll just go through some basics here, right? So if you go to the this page and look at this demo, then you can actually look at an overview, and then the overview is going to tell you a world view of your network. So for example, this is an organization that has offices in UK, in France, in United States, right? So and then you can actually go and say, okay, they have an office in San Francisco. So all these networks are all managed through one single dashboard, which is pretty cool. All the offices they have, and not only offices, people who are working from home. You can see that they have an office in London, in San Francisco, in Sydney, and they have some teleworkers or individual people who have their own private VPNs and things like that that they've created. They work from home, right? And so they're all managed through one dashboard, right? And this could be potentially be hundreds of access points. So let's say we want to go and see what's happening in San Francisco, right? You click on San Francisco, and then it will take you to the page where you see all the list of devices that are currently connected in San Francisco, right? In their San Francisco office, there are 38 devices, and they're not just managing the Wi-Fi access points. They're also managing other devices like cameras, right? Security cameras. They're managing sensors, and they're managing all these other things here, right? So let's say you want to select one of the Wi-Fi access points, and you can actually see what is basically what that access point is doing. So, and you can look at the details, right, about that particular access point. What is its network? how many devices are connected to it. You can see the device view, device list. This is the device list, but you can also see the access points list. So for example, here access points. You click on that, and it shows you a list of all the access points that are available in San Francisco, right? And for each access point, it will tell you how many devices are connected. For example, here is one access point. That is the public IP address of the access point. That is some local private IP addresses. You can select any one of these access points, and you can see more details about how many devices are connected to it, what is its bandwidth utilization, are there any failures or any disconnections or any issues on that network, or any security alerts, or any attacks or anything like that. You can see all the details, and that will allow you to help you to troubleshoot and debug the network. So now you can see that there is a big difference between how residential works and enterprise works. Enterprise is about scale, and it's about managing lots and lots of devices, and you want some form of a management tool that can actually manage all these networks for you very easily, right? And so the user interfaces are different, the way you access is different. This is even showing you live data of how much data rates and how much throughput, what type of devices are there. You can actually go and click and see what type of applications are running. I have to look at where that location is, but it will tell you how much traffic is coming from email, how much traffic is coming from video streaming. Every little detail can be seen. Basically, you can see events, you can see locations of these devices, what type of traffic it's run. All this information is available on this page. So for monitoring what's happening in the network, for debugging purposes, and also for configuring, right? So this is only the monitoring aspect. But what if you want to configure, and what if you want to create a new network, and you want to apply a new policy, or you want to apply new restrictions, or you want to apply new firewall settings, right? All of these things can be done from this dashboard in one location, and it can be pushed to all the various physical access points that are in various locations, right? Which makes our management of this network extremely easy and valuable, right? Again, this is only the high level. I'll go into a lot more detail about control architectures and how the underlying technology works and all of that in a later session. That's going to come towards the end of the course. But I just wanted to give you a high level overview about this. Okay, going back to our slides. Right. So now the question that we get asked all the time. So what's the difference between a Wi-Fi router and an access point? As I mentioned, if it does all of these things or most of these things, we generally refer to it as a Wi-Fi router. If it only does access point functionality, then it's an access point. So what are some of the basic functions that a Wi-Fi router does? Although DHCP is not generally a router functionality, but it is normally done as a part of a Wi-Fi router. So if you have a Wi-Fi router, then it generally does DHCP, right? So what do you mean by DHCP here? For those of you who are new to this, when you connect your phone to your Wi-Fi network, as soon as you connect your phone to the Wi-Fi network, you get something called as an IP address, right? And that is that address that allows you to connect to the internet, right? And that is a unique address that you get within that local area network for you to use for a certain amount of time, right? So the process of acquiring an IP address is done using the DHCP protocol, right? So for example, the client, which is my phone, would actually try to connect to the DHCP server, which is running on the Wi-Fi router, and it will send a discover message, right? It will say, okay, I want to get an IP address, I want to discover. And then the server will give it an offer, and then basically it will provide an IP address. So take a simple example. Let's say you're trying to go to check into a hotel, right? And you have a reservation. So you go into the hotel lobby and you go to the receptionist and say, I have a reservation, right? So then the person at the reception would say, okay, like, let me check what rooms are available, right? So, okay, room number 405 is available. Would you like to take that room? And say, yes. I say, yeah, that's fine. It works for me. And so then they will give me a key, and then they'll reserve that room for me for the duration of my reservation. Let's say I have booked the hotel for 2 days. So they're going to say room 405 is now yours for the next 2 days. And after 2 days, you need to check out, right? And that same room will be given to someone else, right? So same concept. So when I'm going and connecting to Wi-Fi network, the router will check what IP addresses are available, and it will provide me an IP address. And along with that, it also provides me a lease. A lease is basically for how long I have the IP address, and the lease could be for 24 hours, for 1 week, or so many hours, and so on. After the lease time expires, generally I lose the IP address, or I have to renew my lease, right, with the particular router, right? So that's the DHCP functionality, right? So that DHCP functionality actually happens within the Wi-Fi router, right? Now, if it is an access point, if it is an enterprise class access point, the access point is not providing you the IP address. The access point is only being an access point. Remember, I told you that access point is a layer 2 device, right? The access point functionality. So as soon as you send a DHCP request to the access point, it forwards it to the network, and the DHCP server resides somewhere in the network. And then that server responds with an IP address. So the access point is purely a layer 2 device. It's only forwarding information. If it is a packet that is above layer 2, it just forwards it. It doesn't process it, right? But if it is a layer 2 packet, then it will process it. So that's the difference, right? So, but in this particular case, the router is actually processing it and providing you IP addresses. Another important router feature here for a residential router is what we call as NATing, right? Or network address translation or port address translation, right? So this is another important feature, and we don't have much time today, so I'll not go into details. It's hard to explain this within 5-10 minutes, but I have put some nice references, some nice videos in the references link for you to go to watch it. But basically, what is NAT doing is NAT is allowing you to create a private network. So we all know that IP addresses, if you're using IPv4, there are limited number of IP addresses. There are only a few billion IP addresses available, and there are more than a few billion devices available in the world. So if you issue a public IP address to each device, then you'll run out of IP addresses very quickly, right? So to solve that problem, we use this concept of NATing, where the Wi-Fi router will only take one public IP address, right? And then it will create private IP addresses within its network, and it will route between the public and private, right? So that's what the router does. I'll explain that in a little bit more detail. And then the same router also, as I mentioned, does parental controls and firewalls and all these other things. So these are all the advanced features that are part of the router that makes it different from an access point. Okay, so one of the things we'll do in this course is I promise that we are actually going to keep it as practical as possible. One of the most important things is to be able to see technology. I always believe in touching and be able to see and feel technology. That's the reason why I'm showing you these gadgets, right? Because it's much easier to understand something when you can touch and feel it. So Wireshark is one of those tools where you can actually see technology and see protocols, right? And it's very important for anyone who wants to learn about Wi-Fi and to actually know how Wireshark works. And if you are new to Wireshark, basically what Wireshark is doing is when my phone is connecting to this access point, the packets are flowing through the air. I cannot see them with my naked eye, right? So this is guy connecting to this access point. There is some information going from here. There's some information coming back from here. Wireshark, if you tap into that link, it can actually capture those packets and actually show them to you. It's like a doctor having a stethoscope, right? A doctor will not be able to see inside your body and tell you what's wrong with your body, right? So they rely on tools. They will use a steth and they'll put it on your body and then listen to the heartbeat and all these other things, which they will not be able to hear with their normal ears, right? They will use x-rays. They will get an x-ray to see what's inside your body, right? They'll get some tests done. So this is the tools that a doctor uses to actually debug and the problems with your body, right? In the same way, to debug the problems with a network, you need tools like Wireshark, right? And basically, we'll use Wireshark quite a bit in this course. And any technology or any concept that we teach, we are going to show it in captures and so on, right? So similarly, to show the DHCP, so this is how DHCP transactions work. So if you look at a Wireshark capture, this is the Wireshark software. So those who are new to Wireshark, you can actually go download it. It's a free tool. I put some links in the references. So this is how DHCP handshakes happen. These are the packets, and Wireshark are actually capturing these packets. And this is what would actually happen between your phone and your access point or router in your house. When you're getting an IP address, this is what's happening behind the scene, right? So the router is the phone is sending a DHCP discover message to a broadcast address because it doesn't know who will give it an IP address. So it will just send it to a broadcast address. And when it sends that to a broadcast address, then basically the router would respond with an offer. And this is the DHCP offer. And if you look at the decode of those packets, you will be able to see that it is offering basically a particular IP address, right? It's offering an IP address 217, right? And then you can actually then request for that IP address, and then then the clients will send a request and say, I want to request for this IP address 192.168.90.217 or 227, right? And then the server will acknowledge, and then you'll get the IP address. And within this acknowledgement, there will be a lease time, and all those details will be in here, right? In this message, right? So those are the exchanges that happen, and you can see them using Wireshark, and that's how a client or a phone will get an IP address from the server, right? Similarly, if you want to look at NAT, right? This is what happens for NAT, right? The NAT functionality, if you look at, as I was mentioning, remember that there is only one public IP address for this router to connect to the internet. So that is coming from the WAN interface. So each router has, hard to see from here, but it has WAN interface. The one that is blue in color is the WAN interface, and these are LAN interfaces. And this is wireless LAN interface, right? The radios, right? So this port is used to connect to the internet. This is the WAN interface, the blue port, right? When you connect this to your internet, it gets a public IP address. So anyone in the world can get to this router using the public IP address. In this example, it is 18.189.85.200, right? So that's the public IP address this guy has from the internet. Now, what is it going to do with that, right? But we will have multiple devices. Let's say there are 10, 20 devices connected on the LAN side. How does that work? On the LAN side, you have a private network. In this case, it is 192.168.1.x is the private network. And let's say one device is connecting. My phone is connecting to the wireless LAN. As soon as my phone connects, it does DHCP, and I get an IP address from the private network, from the 192.168.1 network. So in this case, I got 192.168.1.53. Right? Similarly, there's another device, and it got a different IP address, 192.168.1.82. To the external world, if let's say I want to send a packet from the internet, which is here from server to this device, this server does not know this address. It only knows this address, right? So it will only send packets to this address, right? But how do those packets get to here? That is where you use the NAT table. So, and we use a combination of an IP address and a port number to actually route to each individual device. So, for example, if the server is sending a packet to 192.18.189.80.200 to this port number, the 32,628, then this router knows that this port number and this IP address combination maps to this private IP address, and then the packets get routed to that address. And if it is going to this port number, then it gets routed to this address, right? And that is how the what we call as port address translation / NAT actually works inside this Wi-Fi router. I know, I mean, it's not very clear. I wish I had more time to explain this in more detail, but we're running out of time, so I'm just going to leave it at that, right? You can also we'll also post some example packet captures. I was going to go through the packet capture analysis to actually show you how that works, but we don't have time, so I'm going to skip that. But I will just post those example capture files in the WhatsApp group for anyone interested. So in summary, what the router is doing is it's doing basically the NATing functionality and the DHCP functionality, which are unique to a residential environment. Okay. Right. So the last thing that I want to talk about today is a high-level anatomy or a functional block diagram of a Wi-Fi access point / router. Right. Again, I'll throw a lot of new terms at you. If you're new to Wi-Fi, there'll be a lot of new terms in this slide. Please don't get worried about any of these things, because this is very high level, and this course is a long course, and we'll go through each one of these things in detail, right? So the basic low level, the fundamental modules or the low level modules are the radio modules that are part of a router or an access point. So normally we have one or more radios. Let's say we have 5 gigahertz radio / 6 gigahertz radio, and then maybe there's a 2.4 gigahertz radio, right? These are the radio modules. And then there are various functional blocks of that radio module that makes the radio module actually function. There is what we call as a transceiver basically which does the transmission and reception functions, transmitting information, receiving information, right? There are filters that would filter from the radio frequencies. There are power amplifiers. There are noise amplifiers and noise mitigation devices. There are all these other blocks that are part of the radio itself, right? And then there is something called as the baseband, right? A baseband is the physical layer. It has many functions. It does automatic gain control. It does modulates, demodulates signals. It does encoding, decoding of signals. It does channel estimation. So we'll get into all these things in a lot more detail. So to give you a very simple example, if this guy is a transmitter and this guy is a receiver, he's sending information, then they're able to see each other, and that is a line of sight, and there is no interference between them. So there is a clear channel in this particular case. But in most real world cases, the channel is not clear, right? Which means that this router could be behind a wall, or this could be some other device, and the signals could be colliding, reflecting, and all of that. And the channel would be change a lot. There could be some noise. Someone turned on a Bluetooth device and raised the noise floor. So there is a lot of things that would change in the channel. So basically the medium between these two, the wireless medium, is called a channel. So channel changes. So you have to adapt to the changing channel, which means that you have to estimate the channel, right? And so there is a channel estimation algorithms and all of these things as a part of it, right? There are lots of other things, encryption, decryption, all those things happen at the baseband level. Then there is the lower MAC, the medium access layer 2, but the functions that need to be very fast are to be done in the hardware are part of the lower MAC, right? So there are some functions like carrier sensing and random access. There is acknowledging frames. There is aggregation. There is interframe spacing. All these things are part of the lower MAC. And then upper MAC does a little bit more software functions, right? Like creating frames, sending out beacons, right? Doing RTS, CTS, virtual carrier sensing, power save functions, DFS functions, rate adaptation algorithms, load balancing algorithms, radio resource management algorithms. These are all various algorithms that are implemented in software inside the access point. That again, I'm throwing a lot of terms at you. Every one of these will be explained in more detail in the coming sessions. And then of course we have the network processor, and then we have the memory modules. The memory is generally distributed into two areas. One is the flash memory, the permanent memory, that actually has certain things like the boot code. So when the system boots up, it needs a boot code. It needs a backup image. Just something gets corrupted, it needs to be in permanent storage. The TCP/IP stack, the device provisioning, the web server that runs on the device, and basically the supplicant, or in other words, the security modules, the security state. All security state is all saved in the flash memory, right? Stats, logs, all those things are saved in flash memory. And the dynamic memory is the packet buffer memory, right? So as you are receiving packets from the air interface from the wireless side, or you're receiving packets from the Ethernet side, they need to actually get into queues, right? And they need to be getting into different types of queues and things like that. And you need to allocate memory for all the packets, right? If you're doing power save, if you're doing various things, then there's a packet buffer or a dynamic memory, right? You also have stored the running image, whatever is the current running firmware, you need to run that there. All these firewalls that I was talking about, rate limiting features, timing features, synchronizing with the global clocks and all these things. Any cloud agents we need to run to connect to the cloud. Remember that this Wi-Fi access point needs to connect to the cloud controller. So you need a cloud agent that connects to the cloud controller. So those things, if you have any captive portal login agents and things like that, when you connect to an access point, let's say you go to a hotel, you connect to an access point, it actually brings up a web page. So that's called captive portal login, right? And then you type in your room number and all of that, and connects to the Wi-Fi network. So those kinds of entities, they run all of these things here, right? And then you have the Ethernet PHY, right? Ethernet PHY has the WAN interface, the LAN interface, the serial interfaces, USB interfaces, and then you have the various modes in which you configure them: bridging mode, NATing mode, VLAN mode, all these other things. So these are in some ways the high-level functional blocks of you call it an enterprise access point or a router, and all these things are doing various things within the device, inside the device, right? Now, as we go along the course, we will actually go through all of this in more detail, and all of these have very specific functions, and we'll talk about that. Right. So just to kind of bring things along and summarize things here, We talked about a lot of things. We talked about the routing functions and firewalls and cloud controllers and management and all of that. That's all great. But at the end of the day, what we are most interested in this course is the job of a access point. I'm not interested in the routing. I'm not interested in firewalls. I'm not interested in all these other things. That's all good to know. It's all around the access point. But this course is about the access point, right? And for the rest of the course, all the modules that we're going through, for the most part, we will get deeper into the access point, because we are not talking about netting and DHCP and all of that. That is good to know. We can learn them from references. But Wi-Fi is all about what the access point does. And what the access point does is only here, right? Only two layers, right? There is the physical layer and the MAC layer that runs inside the access point, and then the physical layer and MAC layer of the client of the station, right? And the interaction between these layers. This is the scope of a Wi-Fi access point, these two things. And most of what we're doing in this course stays within this scope, right? And there is so much to learn here, right? So for example, module 2 talks about WLAN 5 layer, right? It talks about various types of spectrum technology. Someone asked, are you going to talk about spectrum? Yes, we are going to talk about spectrum, OFDM, OFDMA, how channel allocation is done, how frequencies are done, how 5 headers are created, what is MCS rates, what are the various modulation coding schemes, how different 5 rates are created, how the access point rated apps, how it connects to a medium channel, and all of that. All of those things are part of the physical layer. We'll talk about that. We'll talk about wireless LAN MAC layer, right? And there are so many different things: beaconing, management frames, control frames, data frames, how the frame formats work, how aggregation works, how rate adaptation works. There are so many different areas when it comes to the MAC layer. Carrier sensing. How do you actually sense the medium? How do you do multiple access, right? How backup algorithms work, right? So now we are really getting into the core of the technology. So some of you might be wondering, when will Sitaram get into the core of Wi-Fi? Yes, from next session onwards, we are getting into the core of Wi-Fi. And we'll try to explain it in as simple terms as we possibly can. I'm not going to have any formulas, equations. I'm going to use simple examples and try to explain. Okay, module 4 covers security, other advanced topics. Troubleshooting. Module 6 will go into troubleshooting tools, Linux tools, and various kinds of secure tools that are Wireshark, and basically all kinds of tools that we have that allow you to troubleshoot Wi-Fi networks, heat map software, all these other things. We talk about testing and all these things. So these are all the things that will start from next week. From next Tuesday, we'll start with the wireless LAN physical layer, which is part of module 2. And then we'll see you all in the next session. So that's all I had for this session. Here are some references. They'll be posted about Wireshark and Meraki demo and FCC IDs and all these other things. Right.